The matrix. In this video, we will introduce the two-dimensional array, also known as the matrix. A matrix is an array of arrays, or in other words, it is an array where each individual element within it is also an array. Here is an illustration of what a matrix would look like. Notice that whereas an array just has a length, a matrix has both length and width. A row refers to a horizontal sequence of values within a matrix. For example, row 0 contains the values 1, 2, 3, and 4. Row 1 contains the values 11, 12, 13, and 14. And row 2 contains the values 21, 22, 23, and 24. A column refers to a vertical sequence of values within a matrix. For example, column 0 contains numbers 1, 11, and 21. Column 1 contains the numbers 2, 12, and 22. Column 2 contains the numbers 3, 13, and 23. And column 3 contains the values 4, 14, and 24. How would we create a matrix such as this in our program? Well, the first step would be to state the type of values we want the matrix to store, which in this case is integer, so we type int, followed by a pair of empty brackets. By typing a pair of empty brackets, this lets the compiler know that we're creating a matrix and not just an individual array. Then we, of course, will type the name of the matrix. In this case, we'll simply name it mate, which is short for matrix. Then, on the other side of the equal sign, we'll type new int. Once again, we type int because that is the type of value that we want our matrix to store in this example. Then, followed by the number of rows we want inside a pair of brackets, which in this case is 3 because we want 3 rows, followed by the number of columns we want inside another pair of brackets. Here we put 4 because we want our matrix to have 4 columns for this example. What this single line of code will do is create a 3x4 matrix containing nothing but zeros, the default value for integers. Then, to assign the individual values to this matrix, for example, 1, to assign 1 to the top left corner, I would first need to type the name of the matrix, then row 0, column 0, then on the other side of the equal sign, I would type 1, and that would store 1 at row 0, column 1. Then for the number 2, I would type row 0, column 1, equals 2, and that would give me 2 at that location. Next, to get the number 3, I would type row 0, column 2, and that would give me 3 at that location. Then for 4, I would type row 0, column 3, and that would give me 4 at that location. Then, to get 11 on the next row, I would type row 1, column 0, and that would give me 11 at that location. For 12, I would type row 1, column 1, and then that would give me 12 at that location. For 13, I would type row 1, column 2 equals 13, and that would give me 13 at that location. Then for 14, I would type row 1, column 3 equals 14, and that would give me 14 at that location. Then for 21, I would type row 2, column 0 equals 21 to give me 21 at that location, and then so on and so forth. By now you get the point. To store a value at a specific location in the matrix, you first will type the row that you want it stored at, followed by the column you want it stored at. This is just one way to store values in a matrix. We could have also created this exact same matrix with an initializer list. The same way we can use initializer lists for arrays, we can also use them for two-dimensional arrays or matrices. So how would we do that? Well, on the left side would be the exact same thing. We'd once again type the word int, followed by 2 empty brackets to let the compiler know that we're making a two-dimensional array or matrix. Then we'll simply name it mate, which is short for matrix. Then on the other side of the equal sign, we're going to type new int, followed by 2 empty pairs of brackets. This time we're not going to put exact dimensions like we did before because the initializer list is going to determine the dimensions for us, just like it did when we were creating arrays with an initializer list. After that will be a pair of brackets, and inside this pair of brackets will be an initializer list for each row in the matrix. We'd have an initializer list for the first row, followed by an initializer list for the second row, and then initialize the list for the third row. Now, notice that surrounding all three of these initializer lists is a pair of curly brackets. These curly brackets unifies these three individual rows together to make one matrix. Also notice that separating each row is commas. We insert a comma in between each row. The last topic we'll discuss is how to iterate through a matrix. Recall that iterating through something means visiting each element in that object. There are two common ways to iterate through a matrix. You have row major order and you have column major order. What is row major order? Row major order means iterate through each row one at a time, starting with row 0. That means start at row 0, column 0, then go to column 1, then column 2, then column 3, then drop down to row 1, column 0, go to column 1, column 2, column 3, then drop down to row 2, column 0, then column 1, column 2, column 3. How would this iteration look like in code? Well, just as we use a single for loop to iterate through a regular array, we're going to need a nested for loop to iterate through a matrix. And since we're using row major order, the outer for loop will be used for iterating through the rows. Since we're visiting each row one at a time, we'd initialize I to 0, increment it by 1 every single time. But notice that the number of outer loops is equal to the length of the matrix. That's because the length of a matrix always equals the number of rows in that matrix. So, since the outer for loop is what we're using to iterate through the individual rows, the length of the matrix is what we will use to determine the number of outer for loops that we need. Next, the inner for loop will be used for iterating through each of the individual columns. Once again, since we're visiting each column, we're going to initialize j to 0, we're going to increment j by 1, but notice the number of inner for loops is equal to the length of row 0. The reason we put that is because the length of a row within a matrix always equals the number of columns in that row. Also notice that we could have put row 1 or row 2 and would have gotten the same thing because, as you can tell by the picture, row 0, row 1, and row 2 all have the same number of columns. Regardless, the important takeaway is that the length of a row within a matrix always equals the number of columns, and thus that determines the number of inner for loops we will need for a row major order iteration. Then, inside my for loop, suppose my goal is just to print out each value in the matrix in order. What would I use for the first index? What would I use for the second index? For the first index, we're going to use the variable that was used for iterating through each row. In this case, that was variable I. So I would go inside the first pair of brackets. And the second pair of brackets would be the variable that we used for iterating through the columns, which in this case was j. J was the variable that we used for iterating through each column. When we execute this program, we get the values printed out in row major order. Now, what is column major order? Column major order is iterating through each column one at a time, starting with column 0. That means we start at row 0, column 0, drop down to row 1, then drop down to row 2, then slide over to column 1, row 0, drop down to row 1, then down to row 2, slide over to column 2, row 0, drop to row 1 and row 2, then slide over to column 3, row 0, drop down to row 1, then drop down to row 2. How would a column major order traversal look like in code? Well, once again, we're going to need not one but two for loops, a nested for loop. And since we're doing a column major order iteration, the outer for loop this time will be what we use for iterating through the columns. Hence, the number of outer for loops will be equal to the length of row 0, because once again, the length of the row is what gives us the number of columns. The inner for loop will be what we use for iterating through the rows. Hence, the number of inner loops will be equal to the length of the matrix, because the length of the matrix is what gives us the number of rows inside the matrix. Then, inside the inner for loop, if our goal is to print out each value in the matrix, what would we use for the first index? What would we use for the second index? Once again, the first index will be the variable that we used for traversing the rows, which in this case is variable j. The second index will be the variable that we used for traversing the columns, which in this case was variable I. When we execute this program, we get the values all printed out in column major order.